Hello and welcome to Otten Math. In this edition of Otten Math, we're going to talk about quadratic functions and their graphs. We're going to break this into three pieces and talk about standard form first, and then we'll create another video for vertex form, and then finally for intercept form. So in this particular video, we're going to go through a little bit of review, high-level review on quadratics and parabolas and graphing, and the other two videos we're not. All right, so let's talk about the vertex and axis of symmetry. So just some vocabulary to get us started. The vertex is the lowest or highest point of the parabola. So if I have a parabola that faces up, then the vertex is going to be the slowest point, which means there are no values for y that are going to be less than the value here at the vertex. If it faces down, then it's the highest point, meaning there are no greater values for y after the vertex point. We also know that the axis of symmetry divides the parabola into two symmetrical or equal halves. That axis of symmetry goes right through the vertex. So that's very important to understand because in some cases we're going to get the vertex from the axis of symmetry, and in other cases we're going to get the axis of symmetry from the vertex. So we know that both the vertex and the axis of symmetry have the value of x in common. We are not going to talk about parabolas that are oriented right or left, just up or down for this particular video. All right, so x-intercepts are the coordinates where the parabola crosses the x-axis. I can have two real solutions or two real values where the graph crosses the x-axis. I can take the parabola and I can move it up so that it never touches the x-axis, in which case, I have two imaginary solutions, and then I can orient the parabola so that it touches the x-axis at one location, and then I just have one solution. So I can have one solution, two solutions, or one solution, one real solution, two real solutions, or two imaginary solutions. So those are the x-intercepts, place or the coordinate where the parabola crosses the x-axis. And the y-intercept is the coordinate where the parabola crosses the y-axis. I know it's a little funky here because the red line here is our axis of symmetry, and this black line here is our y-axis. So the y-intercept is this point here, and remember it's a coordinate, so it has both an x and y component to it. All right, so let's talk about minimum and maximum values as they relate to the vertex. So the vertex will help us identify the minimum and maximum value. And when we talk about minimum and maximum value, typically we're talking about the value of y for the coordinate of the vertex. All right, so in this case here on the right, if I have a vertex that's negative 2, 16, then my maximum value, the value that is the highest value for y for that given function for the parabola is going to be, let's just say 16 here. So that's my maximum value. Minimum value here you can see is going to be 0. So there are no values in the parabola for y that are going to be less than 0. 0 is our lowest value, our minimum value. So typically the minimum or maximum value corresponds to the largest or smallest value for y from the coordinate for the vertex. All right, so let's get into standard form, and then again we'll talk about vertex form and intercept form later. Standard form, y is equal to ax squared plus bx plus c, where a can't be equal to 0. And these are the things that I want you to be able to do or derive from the standard form. So identify the coordinates of the vertex, identify the axis of symmetry, identify the y-intercepts, identify the x-intercepts, and then we're going to go ahead and graph the parabola once we have these four items. Okay, so standard form, again, y is equal to ax squared plus bx plus c, where a cannot be equal to 0. When the graph opens up, we call this happy face parabola. Graph opens up, a here is going to be a positive value in sign. When it opens down, a is going to be negative. All right, so again, when a is positive, parabola opens up. When a is negative, parabola opens down. So you can see for the first example, opens up. Second example here, parabola opens down. All right, so which way do the parabolas open? Again, up for the first and down for the second, negative sign, positive sign. So the idea here is not for you necessarily to be able to answer this question on a test, but to be able to spot check or identify, once you've graphed the parabola, if in general your parabola is facing in the correct direction. If you see that the parabola is facing the wrong direction, you need to go back and double check your work. All right, so first we're going to talk about finding the axis of symmetry from standard form, and the axis of symmetry is x is equal to negative b over 2a. It's for standard form. So remember, this is a line. So if we go back to this original graph here, this is the axis of symmetry. The axis of symmetry is a line. It is not a number. So when providing the axis of symmetry, please make sure you provide it as a line. X is equal to some value, and that's going to be the case for parabolas that open up or down. So I say muy importante. The vertex has the same value for x as the axis of symmetry. So now we're going to find we're going to use the axis of symmetry to find the vertex, right? So axis of symmetry goes to the vertex. X is equal to some value. That's the line. And then the vertex is going to have this value for x here. So I put it in. Axis of symmetry goes to the vertex. So it's very important to remember that. All right, so here we go. Vertex is a coordinate negative b. See, x is equal to negative b over 2a. Vertex has the coordinate negative b over 2a. And then we need to derive or find the y portion of the vertex. All right, so if you do the math, minus b2 over minus b, which would be minus 2 over 2 times 1, leaves us with negative 1. Right, so now we're going to use negative 1. We're going to substitute it in to this function, right? Y is equal to negative 1 squared plus 2 times negative 1 plus 1, and this is going to be 1. 1 plus 1, and then plus negative 2 leaves us with a value of y for 0. So your vertex is going to be negative 1. Substitute that value in for x here into your equation, solve for y, and you end up with your coordinate for the vertex. Okay, so let's move on. Here is the math behind what I just did. All right, so the y-intercept is very straightforward for standard form. It's just 0, c. 0c is going to be 0, 1. And then we're going to find the x-intercepts. And there are 3 ways we can find the x-intercepts, really 2. One is to factor, and then the second is to use a quadratic formula. So we're going to go ahead and find out that c is equal to 1. And then this is a perfect square trinomial, so pretty easy to factor. Y is equal to x plus 1 squared. So the x-intercepts have the coordinates of negative 1. Well, it's just going to be 1 x-intercept, negative 1, 0, which also, by the way, happens to be our vertex. Okay, so I'm going to leave you to do a couple. Let's just do the first problem here. Y is equal to 2x squared minus 8x plus 5. And then once you finish doing the axis of symmetry, finding the axis of symmetry, the vertex, y-intercept, direction of the opening, intercepts, and then draw the graph. I'm going to pause here for a moment while you take care of this, and then I'm going to come back in a moment, and I'm going to show you the work. Okay, so we're going to find the axis of symmetry, minus b over 2a, x is equal to 2. We're going to use that value to find the vertex, substitute 2 back in for x, and solve. We end up with negative 3. Vertex is 2, negative 3. 0c is our y-intercept, 0, 5. The parabola has a value for a that's positive, so the graph opens up. We need to go ahead, and we can't factor this easily, so we're going to have to use a quadratic formula to find the roots and then convert that into factored form, or where the graph crosses the x-axis. So end up doing the quadratic formula. You can see the work, 4 plus or minus root 6 over 2, comma 0, 2 values. And now we're going to go ahead and identify the graph. Graph opens up, vertex 2, negative 3, axis of symmetry, x is equal to 2, 4 plus root 6 over 2, comma 0, 4 minus root 6, 2 over 2, comma 0, y-intercept 0, 5. Here's a rough sketch of what the parabola should look like. All right, that's it for this edition of Math. This is just standard form. Come back and join us next part when we talk about finding all those 4 components and graphing for the vertex, and then part 3 will be the intercept form and doing the same thing that we just did here, finding x-intercepts, y-intercept, axis symmetry, and the vertex.